in this video, we're going to be looking at the common questions in the topic quadratic expressions and equations. And basically here, we are going to start with expressions, where our first question will be given as simplify 9x squared minus 1 divided by 3x squared plus 2x minus 1. So in this scenario, we need first of all to factorize the numerator, and our numerator here is 9x squared take away 1. So to be able to factorize this one, we need to remember the binomial identities, whereby we know that a squared minus b squared is the same as having a plus b multiplied by a minus b. And so in order to factorize our 9x squared minus 1, we are going to have 9x plus 3x plus 1, which in brackets 3x, we take away 1. And so in this case, we have completely factorized the numerator. Then we go to the denominator, where we have got 3x squared plus 2x minus 1. So we very well know that for any general quadratic expression of the case ax squared and then plus bx plus c, in order to factorize, we need to look for two factors, whereby the product is going to be equivalent to ac and the sum is going to be equivalent to b. And so in our particular case here, our product is going to be equivalent to negative 3 and our sum is going to be equivalent to 2. And so in that case now, we look for two factors such that their product is going to be equivalent to negative 3 and their sum is going to be equivalent to 2. And so for these two factors, we are going to have 3 and negative 1. So these two factors, we put them in our expression such that we are going to have now 3x squared and then plus 3x, and then you take away 1x, and then you take away 1. And so in this case, you pair them, and in the first pair, if we are to factorize, we factor out 3x first, and inside the bracket we are going to be left with x plus 1. And in the second pair, we factor out negative 1, and inside the bracket we are going to be left with x plus 1 again. And now, to completely factorize that, we take now 3x, take away 1, and then we put in brackets x plus 1. Then from there we combine the numerator and the denominator. We had already said that our numerator is 3x plus 1 multiplied by 3x, we take away 1. All these you divide with 3x minus 1 multiplied by x plus 1. And then now after that, looking at the numerator, we can see we have got 3x minus 1, and also in our denominator we have got 3x minus 1. So these two are like terms, hence they can be able to cancel out, and we shall be left with 3x plus 1 divided by x plus 1. And so that way, we have completely simplified our expression. Still an expression, you'll be given that 6x squared plus 35x, we take away 6, all that divided by 2x squared, and then we take away 72. So we've been told to simplify the expression. So in this scenario, we do the same. We go to the numerator, factorize, and then you also go to the denominator and you also factorize. So you look at the numerator here, our product should be equals to negative 36, and our sum should be equals to positive 35. So in that case now, we look for two factors whereby their product is going to be negative 36 and their sum is going to be positive 35. And so here, these two factors are going to be 36 and negative 1. So we insert this in our numerator. So that now in our numerator, we are going to have 6x squared and then plus 36x, and then you take away that 1x, and then you take away 6. So that's now here, you pair these two, such that when you factor out in the first pair, you're going to factor out 6x, so that here you'll be left with x, and then plus 6. And then in the second pair, you're going to factor out negative 1, so that inside the bracket you're also going to be left with x plus 6. And then as usual, you combine this as 6x take away 1 multiplied by x plus 6, and that way now you have completely factorized the numerator. And then now you can go to the denominator, and when you go to the denominator now, you have got 2x squared take away 72. And here now you're going to realize first you can be able to factorize this by factoring out 2 on both terms, so that now you have got x squared and then minus 36. Then you're going to realize that further you can be able to factorize whatever is inside the brackets. When you look at x squared is a perfect square, and also when you look at 36 is a perfect square. So consequently, we can be able to use binomial identities to factorize that. So that now outside the bracket we have 2, and then inside the brackets we have got x plus 6 multiplied by x minus 6. So that way we have fully factorized the denominator. Then we combine the numerator and the denominator, so that now we have got x squared, x minus 1 multiplying x plus 6, all these divided by 2 in brackets x plus 6 in brackets x minus 6. Then from there, we just look for what is common in the numerator and the denominator. You can just directly see there that it is x plus 6 and x plus 6. So those two cancels, and you'll be left with x minus 1, all that divided by 2 in brackets x minus 6. And so in the simplest form, this is going to be 6x minus 1 divided by 2x, and then you take away 12. And so that way now, we have completely factorized our expression. In this question, we'll be looking at the equations now, whereby we are told to solve the quadratic equation by using completing the square method. So for us to use completing the square method, we know that the value of a must always be equals to 1. So the first thing that we do here is we divide by 2 across. So if we divide by 2 across, we are going to be left with x squared, and then you take away 5 out of 2x, and this shall be equals to negative 3 out of 2. Then from there, in order to complete the square, we need to add a half of b squared, both on the left hand side and also on the right hand side. So in our case here, our b is negative 5 out of 2. And so half of that is now going to be negative 5 out of 4. And so on the left hand side, we are going to be adding negative 5 out of 4 squared. And mathematically, to balance the equation, whatever you do to the left-hand side, you must also do it to the right-hand side. So your equation is going to look like that. On the left-hand side, in order to completely factorize, you're going to have x minus 5 over 4, put in brackets squared, and this is going to be equals to the right-hand side, which is negative 3 out of 2, and then plus. If you open up the brackets, you're going to have 25 out of 16. And now, if you completely put these two together, you're going to be left with 1 out of 16. And now, in order to solve for x, we need to find the square root on both sides. So on the left-hand side, you're going to be left with x minus 5 over 4. And this is going to be equals to the square root plus or minus of 1 out of 16. Now, in order to completely solve for it, you simply now take negative 5 over 4, the other side, and when you take it to the other side, it becomes positive. So that now we shall say that our x is going to be positive 5 out of 4 plus or minus the square root of 1 out of 16, which is the same as 1 out of 4. And now our x value is going to be 5 out of 4 plus a quarter, or our x value is going to be 5 out of 4. We take away a quarter. And so in our first case here, it is going to be equivalent to 1.5. And in our second case here, it is going to be equivalent to 1. So that way now, we are able to get values of x, that is 1.5, and also 1. In our question here, the roots of a quadratic equation in x are 1 minus the square root of 2 and 1 plus the square root of 2. Hence, we are told to determine the equation that gives us these roots. So, in other words, we've been given the solutions, so we need to find what quadratic equation gave us these kind of solutions. So, since now we know that our value of x is equivalent to either 1 minus the square root of 2, or our value of x is equivalent to 1 plus the square root of 2. Here, let us make these values to be a bit simplified. So let's make this value to be a, and let's make 1 plus root 2 to be b. And so in this context, if you take a to the other side, it's going to be x minus a is equals to 0. And if we take b to the left-hand side, it is going to be x minus b is equals to 0. Then you can combine the two to say that x, you take away a, put in brackets x, you take away b, is going to give you a 0. You can open up the brackets so that consequently you're going to have x in brackets x minus b. You take away a, x minus b is now going to be equals to 0. If you open the brackets, we are going to have x squared, and then take away xb, and then take away xa, and then all these we add a multiplied by b, so that now this one is going to give us a 0. Then from then onwards, we can substitute back our values of a and b. Remember, this was just to make our working quite easy, so that we do not make some mathematical errors as we try to compute with very huge numbers. So we substitute back the values of a and b now. So that now, in this case, we are going to have x squared. We take away the value of x multiplied by b, and our b is x plus root 2. and then take away x, put back the value of a, which is now 1 minus root 2, and then plus a times b. So when we look at 1 minus root 2 multiplied by 1 plus root 2, we know that that is a difference of 2 squares. And so this is going to be 1. We take away 2. And now this value all is going to be equals to 0. Then now we can be able to open up the brackets so that now we have x squared, and then we take away x minus x root 2, and then minus x plus x root 2. And then now when you take 1 minus 2, we are going to have negative 1. And now this one is going to be equals to 0. Then from there we can put the like terms together. So if we put the like terms together, we have got x squared is all on its own, but we have got negative x minus x, which gives us minus 2x. And then we have got negative x root 2 plus x root 2, which gives us a 0. And then we shall be left with negative 1. And now all this is going to be equals to 0. And so consequently, we can say that the equation that gave us these roots is the equation x squared minus 2x minus 1 is equals to 0. We have been given another expression, but this time you've been told that given that 25x squared minus 20x plus k is a perfect square, find the value of k. So we need first of all to remember that for any perfect square, deriving from the general format of a quadratic expression, that ax squared plus bx plus c, if this quadratic expression is a perfect square, then we should always know that half of b squared shall be equals to the product of AC, whereby this can also be interpreted as b squared minus 4ac is going to be equals to 0, which is the same as having b squared is equals to 4ac. So whichever of these that we are going to use are going to imply that we are having a perfect square. And so in this case, we just need to substitute our values of b, a, and c. So here, our value of b is negative 20. And so we put in negative 20 squared is going to be equivalent to 4 times our value of a, which is 25, multiplied by our value of c, which is k. Then from then, we can say that this is the same as having 400 will be equivalent to 100k. And when we work out that, our k is going to be equivalent to 4. So in the last question of our video, we have been told that a group of people decided to raise 72,000 shillings to buy a generator. They agreed to contribute equal amount of money, but before the contribution, 5 of the members decided to withdraw from the plan, and as a result, those who remained had to pay more to meet their target of 72,000 shillings. If X represents the number of people originally in the organization, expressed in terms of X, the amount each was to contribute originally. So here, what it means is that everybody is to contribute 72,000 shillings. And we've been told, let the number of people in that organization be X. So then it means, if you're contributing 72,000, then each person is to contribute 72,000 divided by X. But then we've been told that before they could contribute, 5 people have left. So if 5 people have left and we are still to contribute 72,000, then it means we take the 72,000 and then we divide by X minus 5. So the expression that is going to represent the amount that each person is contributing is 72,000 divided by x minus 5. Then after that, when the members left contributed 1,200 more than they would have contributed originally. So we want to know the number of people who are in the organization, or in other words, we want to find out the value of x. So in this case now, if we take the value that now they are contributing after the 5 have left, which is now x 72,000 divided by x minus 5, take away the original amount, 72,000 divided by x. The difference between the new amount and the original amount is supposed to be 1,200. And so in this case, we form this expression. So to solve this equation now, we solve as if we are solving two fractions. So the first thing that we do is we get the LCM of x minus 5 and that of x. So in this case, the LCM is going to be the product of the two, which is now x in brackets x minus 5. And then that becomes our denominator. And then in the numerator now, we are going to have 72,000 x, and then we take away 72,000 multiplying x minus 5. And now this is going to be equals to 1,200. Then now we can open up the numerator and also multiply both sides by the denominator, which is x into brackets x minus 5. So if you open the numerator, we are going to have 72,000x, and then take away 72,000x, and then you add to 360,000, and this is going to be equals to 1,200 multiplying x squared, take away 5x, like that. And so in this case now, if you put 72,000x minus 72,000x, then that becomes a 0, and you'll be left with 360,000 being equals to 1,200, put in brackets x squared minus 5x. And in this case, if you divide by 1,200 here, you also do the same to the other side. You also divide by 1,200 on that side. And so in this case, you're going to be left with x squared. You take away 5x, and then you take away 300, and this is going to be equals to 0. So you're going to realize that you have now formed a quadratic equation. And now once you solve the quadratic equation, you're going to get the value of x. So we are now going to get two terms whereby the product should be equals to negative 300 and the sum should be equals to negative 5. So these two are going to be positive, negative 20, and positive 15. So then you substitute these here, and you're going to have x squared, you take away 20x, and then plus 15x, and then you take away 300, and this is going to be equals to 0. Then if you pair them, and in the first pair you factor out x, you're going to be left with x minus 20, and in the second pair you factor out 15, you're going to be left with x minus 20, and this is going to be equals to 0. If you combine the two, you're going to have x plus 15, put in brackets x minus 20, is going to be equals to 0. Consequently, here it means that x plus 15 is equals to 0, or x minus 20 is equals to 0. And now this means that x is either equals to negative 15 or x is equal to positive 20. And since here we were referring to the number of people, then it means it cannot be negative 15 our x must be equals to positive 20. So that is the number of people originally in the organization. Then the last part C, it was telling us that calculate the increase per person as a percentage. So we need to find out how much was each person to contribute originally. So we are to contribute 72,000, and the original number of people we have found out to be 20, meaning that originally every person was to contribute 3,600. And the increase was 1,200. So 1,200 is a percentage increase, is an increase. So we take 1,200 divided by 3,600, and then we multiply by 100%. And when you work out this, you're going to get 33 and a third percent. So 33 and a third percent is our percentage increase per person. And so with that, those are the common questions that we normally find in the topic quadratic expressions and equations. So subscribe and like to get more content like this.